This is lesson 3.3. Find the equation of a line. Our learning objectives are to find a linear equation given the slope and the y-intercept, find a linear equation given the slope and a point, find a linear equation given 2 points, find a linear equation parallel to a given line, and find a linear equation perpendicular to a given line. So we have 5 objectives today. Let's begin with the first. Find an equation of the line given the slope and y-intercept. You can determine the slope and y-intercept of a line if the equation is written in slope-intercept form, which is y equals mx plus b. You'll recall, slope-intercept form is when you've solved for y. You've solved something for y, and you can see the slope and the y-intercept. This is why it's called slope-intercept form. You can see it really easily. Now let's practice doing the reverse. If we're given a slope and a y-intercept, let's write the equation of that line. Or if we are given a graph, let's write the equation of the line on the graph. Here we go. Example 3.24. Find the equation of a line with slope -3/4 and y-intercept 0, -4. Now, if we have slope-intercept form, we can write the equation by simply substituting in m, right? The slope is the letter m, and then the y-intercept value. Okay, so this is the location of the y-intercept here. So let's substitute those things into the equation. We're going to start writing it. Y equals m, which is -3/4 times x, plus b, which is -4. Now, instead of writing plus -4, we could just write -4. So we'll just make it look simpler. Adding -4 is the same thing as subtracting 4. It now looks much simpler. And so this is our result. This is the equation that has slope -3/4 and y-intercept of -4. Let's go ahead and practice writing the equation of a line when we see the graph of it. So example 3.25 says find the equation of the line shown in the graph. Well, first, let's identify the location of the y-intercept. We see the y-intercept is 0, -4. Now, let's identify the slope. Recall that to identify the slope, we look for lattice points, like points that go through the corners of the boxes. It looks like this is a lattice point. Here's another lattice point. So we look for locations where the line crosses through integer xy values. Great. Now we need to see the rise over the run. So I look for the rise. I'm going up 2 units. And the run to get to the next lattice point. Well, that's right 3 units. Okay, so it appears my slope is rise of 2 over run of 3, 2/3. And I've got a positive slope. My slope is positive. It's going up from left to right. So I can now write the equation of this line. I'll start with y equals mx plus b. That's slope-intercept form. And I will input the things I know, like the slope m is 2/3. Rise over run. It's positive. I multiply the slope with x, and then I add the y-intercept. So I put plus on -4. And once again, you'll see I can simplify the plus -4, well, to simply -4. And I am done. This is the equation of the line in the graph. Great. Let's move on to our next objective. We want to find an equation of the line given the slope and a point. And we have a new form of a line that we're going to show you right now. This is the fifth form of a line we've seen. So we've seen vertical lines, horizontal lines, lines in standard form, lines in slope-intercept form, and the final form you're going to learn for lines is this form, point-slope form of a line. So the point-slope form of an equation of a line with slope m and containing the point x1, y1 is y minus y1 is equal to m times x minus x1. Okay, so really fast, this x1 and y1, They are the values of the point that is known. We know this point. Okay, so it'll be an actual point in space that we know. And once again, m is the slope, right? The slope is m. So if we know a point in space and a slope, well, we can use this form of a line. Now, so look at this information. Use point slope form to find the line equation with one point and a known slope. And what we'll do once we get those values input is we'll convert this into slope-intercept form. So we are going to take this equation, point slope form, and convert it to slope-intercept form, which is used most in most linear applications, right? Slope-intercept form is our favorite. It's y equals mx plus b. It's the simplest form of a line. Now, let's go through this four-step process of how to find an equation of a line given a slope and a point. Step 1, identify the slope. Step 2, identify the point. Step 3, substitute those values into the point-slope form that we just discussed. Step 4, write the equation in slope-intercept form. Let me walk you through this process with an example. So example 3.26 says, find an equation of a line with slope m equals negative 1/3 that contains the point 6 comma negative 4. Write the equation in slope-intercept form. Now, when I look at this, I quickly notice they just gave me a point. All right, so that point is like x1 comma y1. That's the first point that we've been given. And they also told me the slope. My slope is given here. So these two things, when we know a point and a slope, we put them into point slope form. That's why it's called point slope form, because we have a point and a slope. Let's use point slope form. Little reminder, y minus y1 equals m times x minus x1. That is point slope form. Now let's input the things we know, like y minus, now look over here, y1 is negative 4. Okay, so I have y minus negative 4. And that's equal to m, the slope, negative 1/3, times x minus x1. Well, x1 is 6. Okay, so I'm going to subtract x1, which is 6. Okay, I've now input the point and the slope into this equation. At this point, you might recognize, wait, if I subtract a negative, I can turn that into a positive. Okay, so whenever we subtract a negative, just take those two minus signs and turn them into a nice big plus sign. Okay, so here it is. I'm turning that into a plus sign. Great. So now that we've done this, we will now proceed to solve this equation for y. We want to get it alone because we want to put it in slope-intercept form. That way we can see the slope and the y-intercept really well. So I'll show you how to do this. First, let's discuss distributing the slope into both of these terms. And now we would also have to subtract 4 from the left to the right. Okay? And that will get y alone. So y equals negative 1/3 times x, because I'm distributing negative 1/3 into x, and then negative 1/3 times negative 6, which a negative times a negative is a positive, and 1/3 of 6 is 2, so I have a plus 2. But I still have the minus 4 that I just subtracted from the left to the right-hand side. Okay? And now, if I add 2 minus 4, these are two constants that I can combine together because they're like terms. So I'll write my final result as y equals negative 1/3 times x, and then minus 2. I just took positive 2 and I subtracted 4. I combined those like terms to get a minus 2. This is now in slope-intercept form. I'm done. Now, little reminder, slope-intercept form is when I have the variable y by itself on this side of the equal sign, and I've got a slope multiplied with x, and I have a y-intercept. I can see them clearly. Great. Well, let's move forward into the next example. This is example 3.27, and it's to find an equation of a horizontal line that contains the point -2 comma -6. Write the equation in slope intercept form. Now, a little reminder for you, a horizontal line. Well, a horizontal line is a line that is flat. Yeah, so little drawing here, it's a flat line, and a horizontal line has a slope of 0. That's its slope. Now, here I have a point like x1 comma y1. That's my point. And I know the slope of the horizontal line, it's 0. So I can plug this into point slope form of a line. So I take y minus y1 equals m times x minus x1. That's my starting point. That's point slope form of a line. Now let's input the values of the point, right? X value and y value. So we'll put those in for the x1, right? The x1 is the value, x value of the point. Y1 is the y value of the point. So writing this, I get y minus -6 equals m. Well, m is the slope of this horizontal line, which is 0. So I put 0 times x minus, well, x1, which is -2. Okay, so there we go. And at this point, you'll notice this happen again. I have the subtraction sign of the formula and then -6, and I have the subtraction sign of the formula and then -2. So I will turn those double negatives into positives. Now, I'm going to put this in slope-intercept form. So let's first distribute 0 into both of these terms, okay? And we're also going to, in the process, subtract 6 from the left side to the right-hand side of the equation. So now I get y all alone, y equals, well, 0 times x is 0. That cancels. And 0 times 2 is also 0. That cancels. So all of this stuff just becomes 0 because the slope was 0. And then that -6 afterwards is all that's left. So I get an equation that says y equals -6. Now, y equals -6 is a horizontal line. Okay? Great. So it makes sense that we have now found that horizontal line. And that horizontal line happens to pass through -6, right? This value. Okay? Great job. We're done. Well, our next objective is to find an equation of the line given 2 points. So I'll give you a 4-step process to do that. So here's how to find an equation of a line when you know 2 points. Step 1, find the slope using the given points. Now the slope formula, you learned this in the last lesson. The slope m is equal to y2 minus y1 divided by x2 minus x1. Here's a little more context. We put the difference of the y's on top because y's are the rise. And we put the difference of the x's on the bottom because x's are the run. So this is literally rise over run. Okay? Now, once we have found the slope from, between those 2 points, we then move on to step 2. We choose one of the given points. Step 3, substitute the values into the point slope form of a line, right? So we know the slope now, so we plug it in right there. And we know 2 points, just choose one of those 2 points and plug them in for x1 comma y1, right? Just choose one of the points you know. Plug it in there. Now step 4, write the equation in slope-intercept form. I'll talk you through this 4-step process with example 3.28. So it says find the equation of a line that contains these points, -3 comma -1 and 2 comma -2. Write the equation in slope-intercept form. Great. So this first point, it's called x1 comma y1. And the second point is x2 comma y2. It's our second point. So we're going to plug that into the slope formula. M equals y2 minus y1 divided by x2 minus x1. So that will be, I'll show you, y2 minus y1 divided by x2 minus x1. Let's plug in their values. So I have negative 2 minus negative 1 divided by 2 minus negative 3. All right, once again, you see the minus sign of the formula, right? There's the minus sign of the formula. And then the value right here, negative 1. And so we got a double negative that will turn into a plus. And once again on the bottom, that also happened in this case. So I'll turn both of those into big plus signs. And now I have negative 2 plus 1, which is negative 1, divided by 2 plus 3, which is 5. I have now found my slope. I'm going to pull that negative out front. Okay, so my slope is negative 1/5. Now that I have found the slope, I can use the slope and a point, plugging them into point slope form. And you could choose either one of the points to plug in. Okay, so I'll just use the first point here. And so you know that point slope form is y minus y1 equals m times x minus x1. We've been writing that a few times now today. Now let's take the value for m, right? We found that m is negative 1/5. That was all the work we did. And so we're going to plug that in, and also we'll plug in the point. Okay, so y1 is negative 1. Here it is. That's y1. So I'm subtracting negative 1. And that equals m, which is negative 1/5, times x minus x1, which is negative 3. Okay, now once again, you see the minus signs from the point slope formula, and y1 and x1 were both negative values, so we got those double negatives in there. And so we'll turn those into plus signs. Great. And now our last step is to take this point slope form and convert it to slope intercept form. That's step 4, right? So let's take this. We'll convert it to slope intercept form. And you've gone through this process a little bit with me. We have to distribute the slope into both of those terms and also subtract 1 from the left side of the equation to the right side of the equation. Let's clean it all up. We've now got y all by itself because we subtracted 1 to the other side. So I'm going to write y equals. And now we distributed the negative 1/5 into x, and we got negative 1/5 times x. Great. And now we are distributing the negative 1/5 into 3. So negative 1/5 times 3 is negative 3/5. And now we still have that minus 1. Okay, so we have that minus 1. And these are like terms. These are constants here that we can combine together to finish everything off. Now I'll show you a great little trick. See, negative 1 can be written as 5/5. 5/5. Okay? So I see this denominator of 5, and I do a cool little trick. I turn this 1 into 5/5. Like that. And that allows me to now combine my fractions together, right? 1 is 5/5. Anything divided by itself is 1. So now I have the same denominator, and negative 3/5 minus 5/5, that's equal to negative 8/5. So I'm going to combine these two fractions together into negative 8/5. And now I have the y-intercept. Great. We've cleaned everything up. Let me tell you one last time what we just did. First, we found the slope, okay? And that was found by taking y2 minus y1 divided by x2 minus x1. y2 minus y1 divided by x2 minus x1. That's what we did. And we cleaned it all up, and we got negative 1/5. We now chose one of the points. I chose this first point. You could have chosen this point. It doesn't matter. And we substitute those things into point slope form, right? So I wrote point slope form. I substituted in y1 and x1 and the slope. And then I did some algebra to solve for y and get this thing into slope intercept form. Great. Let's look at example 3.29, which will give us another opportunity to go through this process. Here we go. Find the equation of a line that contains the points -3, 5 and -3, 4, and write the equation in slope-intercept form. Okay, so here I go. First, I want to find the slope, m. It's y2 minus y1 divided by x2 minus x1. And you could have called this first point x1 comma y1, and then the second point x2 comma y2 to help you. So you can write that out if you like. And now let's input those values, right? y2 minus y1 divided by x2 minus x1. That's what I'm about to input. And so I take 4 minus 5 divided by -3 minus, careful, -3. So I have the minus sign of the formula and the negative value of x1. So now it's time to turn that double minus into a plus, and 4 minus 5 is -1, and -3 plus 3 is 0. Now this is interesting. I found the slope is -1 divided by 0. But if the run is 0, well, that means that this is a vertical line. In fact, whenever we divide by 0, we call that something. We call that undefined. That's what the name of the slope is. Okay? So the slope is undefined because when we divide by 0, the slope is called undefined. Now, that creates a vertical line. Okay, so we know based on the slope that this is a vertical line. And now the vertical line passes through -3, x values of -3. We notice, see, both of these x values are the same value. And that's why we got 0, right? We took this x value, subtracted this x value, which became a plus, and it all canceled out. That means there's no run, and that's why this is a vertical line. So we could stop right here and say the equation of that line is x equals -3. This is the equation of that vertical line. We could also go through the point slope form process. So I'll talk you through that very fast. We have y minus y1 equals m times x minus x1. But we would encounter a problem because we found that our slope is undefined. Well, this being undefined makes it really hard to proceed because this isn't a numerical value, it's undefined. So it seems to me like you would have to recognize that the slope has a run of 0, and that creates a vertical line, and a vertical line is written as x equals a number, and that number x was here and here. It's both the x1 and the x2 values. So that's how we write the final equation of this line. Great. Hey, we have seen that we can use either slope-intercept form or point-slope form to find an equation of a line. Which form we use depends on the information we are given. All right, so when do I use slope-intercept form? Well, I use slope-intercept form when I know a slope and a y-intercept. Okay, so I'll use that form. Now, when do I use point-slope form? I can use it when I know a slope and a point, right? Because I plug in the slope and that point, x1 comma y1, into the equation. And I can use point-slope form when I know 2 points. I take the 2 points and I find the slope using the slope formula. And then I can just plug in that slope, and then I pick one of those 2 points to plug in right here, and then I can clean it all up to slope-intercept form if I like. All right, let's move on to our next objective. Our next objective is to find an equation of a line that is parallel to a given line. Now, suppose you need to find the equation of the line that passes through a specific point and is parallel to a given line. Please recall from our last lesson that parallel lines have the same slope. Their slopes are equal to each other. Okay, so let's use the point slope equation based on this information. Okay, so example 3.30 says find an equation of a line parallel to y equals 2x minus 3 that contains the point negative 2 comma 1, and write the equation in slope-intercept form. Great. So since we know that the line has to be parallel to this line, we know that its slope must be 2. Parallel lines have the same slope. So we can use point slope form, y minus y1 equals m times x minus x1. And we'll plug this point in for x1 comma y1. And we will plug this slope in for m. Great, let's do it. Y minus 1 equals 2 times x minus negative 2. Right, so I had the minus sign of the formula, and then I have the negative value of x1. So now that I have written this in point slope form, the last thing to do is write it in slope intercept form. So we'll distribute this 2 into both of these things, and we will add 1 to the other side. We're solving for y, and we're cleaning it all up. Now, by the way, this minus negative becomes a plus. I'm distributing 2 into both of these, and I'm adding 1 from left to right. Now I end up with y all by itself equals 2x, right? So 2 is distributed to x, 2x. And then plus 4. 2 times positive 2 gives me a plus 4. But then I had a plus 1 after that. So I'm going to add that 1. And then I'll combine the constants. The constants, 4 plus 1, will give me 5. So I'll just clean this up right away. And there we go. This is the equation of a line that is parallel to this line. And it contains this point. Okay, there we go. Now let's finish by talking about, we'll talk about finding an equation of a line perpendicular to a given line. And so suppose you need to find the equation of the line passing through a specific point that is perpendicular to a given line. Recall that perpendicular lines have negative reciprocal slopes. All right, so in our last lesson, we talked about how perpendicular lines are at 90 degrees to each other. They're at right angles, and their slopes are always negative reciprocals of each other. Little reminder for you, if I had the slope of 2/3, the negative reciprocal of 2/3, well, is negative 3/2. Okay, so we would change the sign. If this is positive, it becomes negative, and we flip the fraction, so the bottom becomes the top and the top becomes the bottom. This is what it means for slopes to be negative reciprocals of each other. Well, let's go ahead and dive into example 3.31. And it says, find an equation of a line that is perpendicular to y equals 2x minus 3. And it contains the point negative 2 comma 1. Write the equation in slope-intercept form. So you'll see that this is incredibly similar to the last problem. In fact, it has the same line, y equals 2x minus 3, and it has the same point, negative 2 comma 1. But instead of finding a line that is parallel to the given line, we want to find one that's perpendicular to the given line. Great. So let's get started. We can write point slope form, y minus y1 equals m times x minus x1, like this. And we can plug in the things that we know. So I start y minus, well, y1, which is 1, equals the slope, m. Well, we need a slope that is the negative reciprocal of this slope, right? Because we need these lines to be perpendicular to each other. So I'm going to help you by putting just this division by 1 under that 2, right? because any integer is really a fraction, right? 2 is 2 divided by 1, or 3 is 3 divided by 1, etc. So we could always turn an integer into a fraction. And why does that help? Because I need to take the reciprocal of 2 over 1. Okay, so it becomes 1 over 2. And I need the negative reciprocal of it. So I would put negative 1/2. Okay, so I have now found the negative reciprocal slope of this slope. Now I proceed. I multiply that by x minus x1. Well, x1 is negative 2, so I'm going to do x minus negative 2, like that. And now, yep, you got it. I have a double negative, so I'll turn that into a big plus. And I need to convert this now into slope-intercept form. I'm going to distribute the slope, and I'm going to add 1 from the left side to the right side. And I'll clean it all up. I've solved for y, and it equals, well, negative 1/2 times x. Okay, so I just multiplied negative 1/2 times x. And now negative 1/2 times 2, which gives me negative 1. And then I still have that plus 1 that I added to the other side. Okay, and now I combine the constants, and negative 1 plus 1 is 0, right? So I can rewrite negative 1 plus 1 as, a plus 0. But then any addition or subtraction of 0 is made invisible because adding 0 does nothing or subtracting 0 does nothing. So we can simplify this and we can make it so that our final answer is y equals negative 1/2 times x. So what have we just found? We just found the equation of a line that is perpendicular to this line and passes through this point. That is what we have found. Okay. Now, this is that how-to step process, right? What did we just do? Well, we found the slope of a given line. Then we find the slope of the perpendicular line. Then we identify the point. Then we substitute the slope and point values into point-slope form of a line. And then we write the equation in slope-intercept form. All right, so this is that process that we're using. Now, here are a couple last examples, and they are kind of special examples because they are either horizontal lines or vertical lines. In this case, x equals 5, that's a vertical line, and y equals negative 3, that's a horizontal line. Now, we need to find an equation of a line that's perpendicular to this vertical line. And you have to think about it for a second. If you have a vertical line, x equals 5, I'll write that vertical line. What type of line is perpendicular to a vertical line? Well, it would have to be a horizontal line. See, they form right angles with each other. So the answer to this question, right, I'll write this out. So a line perpendicular to a vertical line is horizontal. That's important to know, okay? And so if we want to find the equation of that line, well, a horizontal line would just be y equals a number. And all we need to do is look at the y value of the point that this horizontal line would pass through. It's at negative 2. The y value is negative 2. So y equals negative 2 is the solution. That is a line perpendicular to the vertical line x equals 5 that passes through the point 3 comma negative 2. Okay, so the value we set y equal to is right there, just the y value of the point. Now, let's go ahead and look at example 3.33 to finish today. Find an equation of a line that is perpendicular to y equals negative 3 that contains the point negative 3 comma 5. Write the equation in slope-intercept form. Great. So I've got this line, y equals -3. Now that's a horizontal line. And if I have to find a perpendicular line to a horizontal line, that would be a vertical line. Let me break that down for you visually again. So y equals -3, our brains immediately tell us that's a horizontal line. And what type of line is perpendicular to a horizontal line? Yeah, you got it, a vertical line, because they form right angles with each other. And so I could write that exactly like I wrote here, right? I won't write it all down, but I'll just say it out loud. A line that's perpendicular to a horizontal line is a vertical line. Great. And so a vertical line would be of the form x equals a number. And that number is the x value found in this point. So I take -3, and that's the x value of that point. So I know the vertical line would have to pass through that specific point. And that's the solution. So these last two problems, they're more about critical thinking and realizing that if I know a vertical line, then I know a horizontal line is perpendicular. And so I'll write the equation of that horizontal line simply by looking at the y value of the point. And conversely, I could do that with a horizontal line. If I have a horizontal line, well, a line that's perpendicular to a horizontal line is a vertical line, and that's written in the form of x equals a number, and that number has to be the x value of the point that it goes through. And we have completed lesson 3.3, and I hope you have a great day.